It is now time to discuss the quotient rule. And the quotient rule is how you take the derivative of something that looks like a fraction, where you have a function in the numerator and a function in the denominator. And this is important, very imperative, that when you learn this rule, you're careful to pay attention to where you start and you're careful with the subtraction that's in the numerator. So let's look at the rule typed up. All right. So if you look at this first one right here, it says if you have a function that is some function in the numerator and some function in the denominator, then if you take its derivative, this is using math, the description of what it is that you're going to do. And so what it says you're going to do is you take the function that's in the bottom, that would be g, and you multiply by the derivative of the function that's in the top. That would be f prime. And then there's always a minus. And then you take the function in the top and multiply it by the derivative of the function in the bottom. Now, addition, it doesn't matter which way you add. It doesn't matter if you add the first to the second or the second to the first. But it makes a big difference if you're subtracting. The first minus the second is not the second times the first. So you have to start with the bottom. You know, we're taught to read top down, left to right, but you're going to start with the bottom, right? So it's the bottom times the derivative of the top minus the top times the derivative of the bottom. So you start with the bottom, and that's all over the bottom squared without a derivative. There's no derivative in the bottom squared. Okay, you can do this. Trust me, you can do this. Okay, so let's start off and say we have a function, and it looks like x plus 1 over x minus 2. We're going to start easy. Okay, you can do this. You're a calculus student. All right, here you go. You went through all the other math classes. You can do this. Keep telling yourself, especially when you get to the chain rule, keep saying, I can do this. I can do this. All right, here you go. Sure you can. So we're going to take the derivative. So we change this to y prime. And we start with the bottom times the derivative of the top. And the derivative of x plus 1 is 1 minus the top times the derivative of the bottom. And the derivative of x minus 2 is 1 all over the bottom squared. Okay? Then we simplify the top. So this would be x minus 2 minus x minus 1. I see students forgetting to distribute that minus over there. Over x minus 2 squared. Keep going. So these zero out, and you have minus 3 over x minus 2 squared. Not too bad. What do you think? Now, as we go through all these rules, some people have different strategies. So some people see the initial problem, they start working on it, then they follow through with what I do and see if they have the same answer. Let me know if we disagree. And some people just follow it all the way through and then do a problem on their own or something. So stop, feel free, stop this, look at it. If you get lost for a second and you're going, wait, what just happened? The beauty about these recordings is that you can stop, breathe a minute, back it back up and try it again and say, oh, okay, that's what happened. All right, so here we have another thing that looks like a quotient. That's why they call it the quotient rule. It's a fraction looking thing because it's the top divided by the bottom. That's why it's a quotient. So they're not all x's. So let's practice one that's in terms of t. And we're going to take the derivative. So you start at the bottom. So it's the bottom times the derivative of the top, which the derivative of t squared plus 1 is 2t, minus the top times the derivative of the bottom, and the derivative of t squared minus 1 is 2t, all over the bottom squared. Okay? So when you multiply this out across the top, you would have 2t cubed minus 2t minus 2t cubed minus 2t all over t squared minus 1. So these go to 0. You have minus 4t over t squared minus 1 squared. Alrighty. This one, let's try this one. All right. Now, I want to start kind of getting you to start thinking that just because you get an answer and you think, okay, that's it, you need to take this last minute, look at it and go, am I sure I'm done? Okay, so we're going to practice that on this problem. So let's take the derivative, it's the bottom, times the derivative of the top. So we would have our 9. We bring the 5 halves down in front to multiply. So that'd be 45 halves. X. Take 1 off the power. So 5 halves minus 1, which is 2 halves, right? Leaves you 3 halves. Okay, and the derivative of minus 2 is 0. So remember, it's the bottom times the derivative of the top minus the top times the derivative of the bottom, and the derivative of x is 1, all over the bottom squared. Okay, so when we multiply this out, we have 45 halves x, and x to the first times x to the 3 halves is x to the 2 halves plus 3 halves, which is back to the 5 halves again, which makes you wonder if you got stuck in a loop. Okay, all right, minus, and 9x to the 5 halves times 1, and minus and a 1 is plus 2. So 45 halves minus 9 is 45 halves minus 18 over 2, right? So this turns out to be 27 halves x to the 5 halves plus 2 over x squared. All right. Now, there's a lot of kind of rules that you've learned over the past that when you get to calculus, they kind of go, oh, okay, depends on your teacher. Okay, so sometimes depending on your teacher, they'll let you leave the square roots in the bottom of the fraction. They'll let you leave negative exponents just as they are. But one of the ones that no one likes is if you have a fraction inside of a fraction. So this has to go, right? So now we got to figure out what to do with that. And depending on your comfort level and what you've been exposed to in math before, you may know exactly what you're going to do with it right now, which is to drop the 2 down into the denominator. But let me show you another way to get it there. Okay, and the other way you could get it there is to multiply top and bottom by 2, right? Because that's the least common denominator. We had a video on that earlier, and that would work, right? If you multiplied everybody by 2, you would have 27x to the 5 halves plus 4 over 2x squared, right? But I want to try something just a little bit different. There's nothing wrong with any of these approaches. So if you sit here and go, okay, I'm going to factor out a 1/2, Then out of the numerator, that would leave you 27x to the 5 halves, correct? And then something has to go down here where this 2 was, and you are in a, because this will help later. Okay, so in effect, what you're saying is 1/2 times what goes right there would get me back to 2. And so this has to be 4, right? Over x squared. Okay. And then this 1/2 would essentially pull out in front. And you would have 27x to the 5 halves plus 4 over x squared times a half, which is 27x to the 5 halves plus 4 over 2 x squared. Now, it took a little bit longer to do it that way. Okay, whereas multiplying top and bottom by 2 would have gotten me right there right then. But sometimes depending on problems that are coming up in the future, you have to use an approach where you pull out something and then change this even though it was perfectly happy before, and now you have to go, what would it have to be now to make this be a true statement? So I just wanted you to kind of get used to it. Now, sometimes when, especially if you're doing computerized homework or whatever, sometimes your computer is gonna sit here and make you do, or not your computer, but the software. Okay, it's gonna say, all right, I'm gonna split this up, and it wants you to split it up since there's a monomial down here. Okay. So then you go, okay, well, this side is just going to be 27 over 2, but this, so 27 over 2x, and 5 halves minus 2, which is 4 halves, right, is going to leave you a half plus 4 over 2x squared, right, is 2 over x squared. And then they sometimes change it to this, 27 square root of x over 2 plus 2 over x squared. Now, let me kind of compress this down. Oh, yeah. Okay. Now, for instance, if you were in my class, I'm expecting this answer. Okay? But your teacher and my expectations as a teacher may be different, and that's okay. Okay, that is actually okay. But let me tell you why I would be all right with that. And I would not be okay with this. Is because do you see that this format right here, the way it was given to you, it was not given to you with a radical. Okay, it was not given to you with a square root on it. And so that was not there. And it was given to you as a single fraction, right? This is a single fraction. Down here, you have acquired a square root, which was not in the original formatting, and you have split it into 2 fractions. And I would not want this. Now, depending on the computer, the computer is not a person, the software is not a person's brain. And so, depending on what data you have to put in, sometimes they want you to do that. But oftentimes, one of the reasons they want you to return it back to its original form is because not only is that good form, okay, but if you have to take the derivative and do something else to it, like graph it, then what you would have to be doing is taking this form out and changing it back to that form so that you can get it graphed using the processes that we do. So separating it into 2 fractions is not helpful. If your computer software makes you do that, well, you just do what you have to do, okay? But it is not really very helpful. Now, let's do another problem. This one requires some concentration on your part. So if you've been kind of just sitting back and taking it easy and watching this show because it's so entertaining, all right, then you need to kind of deep breath, right? And if you've been struggling to keep up with what we've done so far, I want you to take a deep breath too, but I want you to try to relax. Um, Turn off the TV or whatever's going on, or if someone's talking to you, go, can you give me just 2 minutes? Okay, I have to concentrate on this next problem. 2 minutes. I'll help you in 2 minutes. All right. So let's do the derivative. Okay. Now, this one is not just a function over a function. This is the product of two functions over a function. So when we do the derivative of the top, we're going to have to do the product rule. Okay? So we've got the quotient rule, we've got the product rule, and this is actually kind of the start of the chain rule, okay? Where you've got a rule inside of a rule. Okay, now we've been doing that. We've had a rule, we've taken the derivative of a power inside, but that usually is not as upsetting as the product rule and the chain rule. So here we go. If you just keep narrating the English rule to yourself, it will help you get through this. And on a test, okay, so it's the bottom. I don't care what the bottom looks like. Times the derivative of the top. And then you look at the top as if nothing else in your life matters, okay? And you go, oh, that's a product. And then you switch gears and you say, now what was the product rule again? Okay, so the product rule is the first, okay, times the derivative of the second, which is 3, plus the second times the derivative of the first, which is 1. Now the danger here is you're halfway, you're not even halfway through the quotient rule. So sometimes people get distracted and forget to complete. So let's see where we're at. So this is the bottom times the derivative of the top. That's all we've got so far. Okay? Minus the top times the derivative of the bottom, which is 1. Okay? So here is the top times the derivative of the bottom. I can't even write derivative up there, but you get it. Derivative. Okay. All over. Don't forget this. The bottom squared. Okay? And now, if this is kind of an intense problem, this would not be a 5-point problem for me. This might be like 8 points. Okay? If this was an 8-point problem, on this line right here, you're only going to get 2 points. The other 6 points are the cleanup that comes after this. And if you have a teacher that says you can just stop right here, you may be congratulating yourself that you don't have to do the rest of this, but I can guarantee you that in your future classes, you're going to wish you had cleaned them up because you have to do that in other classes. So don't be so happy that you're not having to do that right now. Still go ahead and practice cleaning them up so that you're ready, okay, when you have a different teacher or you have other classes, because I can tell you that for engineering, you're going to have to know how to do this algebra, okay? So please practice this, all right? And if you have a teacher that makes you clean it up, you need to tell them thank you, okay, for having you do that. Well, you do really need to tell them thank you. All right, so let's clean this up. Now, so what's going on in here? And depending on your teacher, they may be okay if you kind of do some minimal cleanup work in here, okay? So this right here is 3x plus 6 plus 3x minus 5, right? And this over here is going to be 3x squared plus x minus 10. This is probably bad form for me to show you, but Most teachers will be okay if you do that. Now, what we would have here then is x minus 4 times 6x plus 1. That's what's left over from that one right here. Okay, minus this 3x squared plus x minus 10 over x minus 4 squared. And this turns out to be 6x squared minus 23x minus 4 minus 3x squared minus x plus 10. And you have 3x squared minus 24x plus 6 over x minus 4 squared. So that wasn't too bad, right? One more. All right. This one may make you go, wait a minute, I don't know about this. I need to practice some more. That's good for you. If your brain is going, I don't know, what that says is you need to do some more practice. So it's good. You would rather your brain says that now than on the test, right? All right. So practice. You have to practice and you have to narrate consistently all the time on every problem. Derivatives do not understand this radical thing. They understand powers. So you have to rewrite it. Okay? And here we go. The derivative is the bottom times the derivative of the top minus the top times the derivative of the bottom. And the derivative of x to the 1/2 is 1/2 x. Take 1 off the power, and the derivative of 1 is 0. So it looks like this. All over x to the 1/2 plus 1. Now I have a big finish for the end of this problem, so hang in there with me. All right, here you go. So now we're going to do massive cleanup. Okay, this part, x to the 1/2 plus 1 times 1 is thankfully just itself. Okay, minus x times 1/2 x to the minus 1/2 is 1/2 x to the first times x to the minus 1/2. You write the x down and add the powers, right? Okay. And then you have this minus times this minus 1 times this. So you have plus 1/2 x to the minus 1/2. Sometimes when you have a bunch of unexpected terms running around, I forgot to square the bottom. You have to, because I was worried about my big finish. All right. And if you caught that, good for you. All right. And again, I would fib and say, I was just seeing if you were paying attention, but I was so busy thinking about my big finish that I wasn't paying attention to where I was at. So learn from my lack of concentration for a second. All right. Now, so sometimes it just makes your head kind of ache, but you can do this. All right. So you have, here's an x to the 1/2. And here's an x to the 1/2. And the other one is an x to the minus 1/2, so that's not a like term. So let's see what we've got here. So 1 x to the 1/2 minus a half of an x to the 1/2 is a half x to the 1/2. Okay, you all right? Okay. Plus the 1/2 x to the minus 1/2 plus 1, that's what's left on the top, over x to the 1/2 plus 1 squared. Okay? Now, you can multiply top and bottom by 2. So multiplying through by 2, you have x to the 1/2 plus x to the minus 1/2 plus 2 over 2 x to the 1/2 plus 1 squared. Okay? Now, see this x to the minus 1/2 right there? Let's factor that out because this looks kind of interesting between this concept of this x to the 1/2 plus 1 squared and this part that's going on in the numerator. Let's explore this just a little bit more just in case. All right, so here we go. So because if you look back up in here, we didn't start off with negative exponents, but let's look and see. So I'm going to factor out an x to the minus 1/2 out of the top. Okay? So x to the minus 1/2 times something right here has to multiply back to this x to the 1/2. So x to what power right here would go minus 1/2 plus this would get me 1/2. Okay? Minus 1/2 plus 1 would get you that 1/2, right? Okay. Plus x to the minus 1/2 times something right here has to get you back to this. Well, that would be 1. 1 times that is that, right? Plus, okay, I had a 2. Now, x to the minus 1/2 times something gets me back to just a plain 2. So what does this power right here have to be? So that minus 1/2 from here plus something here gets you no x's at all up there, right? Now remember, powers add. So 2x to the 1/2, you would go x to the minus 1/2 times x to the 1/2 is x minus 1/2 plus a half is 0, right? Because you're going to have to do this in the chain, simplifying some of this chain rule stuff. So we're just starting here. All right. So multiply this out if it's kind of making you queasy. Okay. Multiply this out so you can see what's going on. And this is what we had. This is where we were, right? Okay. So I can move this negative exponent down here. Here's my 2. Here's my x to the 1/2 plus 1 squared. And here's x plus 1 plus 2 x to the 1/2. Okay. Now I'm still kind of thinking, I don't know, okay, about this binomial square and that trinomial that's on the top. So I'm going to wander over here and let's pretend it's your test paper. So you're going to wander over here and see what this would be if you squared it out. Okay, so doing the FOIL method, the first, x to the 1/2 times x to the 1/2, right, is x. Add the powers together, x to the first. Then you'd have x to the 1/2 times 1 plus x to the 1/2 times 1 plus 1 times 1 is 1. So this is x plus 2 x to the 1/2 plus 1. Okay, and you see this and that. So this is my big finish, y'all. Okay, this, that binomial square is that trinomial that's in the numerator. Okay. And all the hair on your arm should be standing up going, this is so cool. Okay. So then you go, oh, this is 1 over 2 x to the 1/2 because this is going to cancel this out. And then you go, wait, 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 wait. Let me look. Oh, it started with a square root. So this is 1 over 2 square root of x. We made it. All right. Here you go. Got to have fun, y'all. Got to have fun with these or you're just going to drive yourself crazy. So this is the end of the quotient rule. I'm so proud of my finish on this problem. I'm not even going to have you do a tangent problem right here, but you can find a tangent to these curves as well. But we're going to stop the quotient rule right here. The next video is going to be the chain rule. And the chain rule is so intricate that I'm actually going to break it into 2 videos so that you're not overwhelmed by a really long video that has all these moving parts in there. And then at the end of that, I'll move into the derivative of trig functions, and then we will revisit the chain rule and trig functions. Okay, so hang in there. You can do this. Okay, keep telling yourself, I'm in calculus. I can do this. I made it through all these other math classes. I can do this. Okay, and you can. And if you're having trouble, go find some help. Okay, so you can do this, and I'll see you at the chain rule.